Hello everyone, I wish everything is okay. I'm Ayoub Berrag, PhD student in University of Sid Mohamed bin Abdullah, Morocco. I will present in front of you our article which is PyFed extending PySyft with no N-IID Federated Learning Benchmark, a part of Canadian conference that will take place virtually in Vancouver 25 May to 28 May 2021. We will follow this outline. First, we'll introduce what is federated learning, how does it work, and also some features of our framework. Then we'll discover the architecture and the pipeline of the PyFed framework. We will discuss some ways to handle the subgenres of the federated learning and also the benchmarking results using our framework. Then conclusion. The federated learning is a decentralized machine learning approach that aims to secure the data of users and also decrease the bandwidth of the training. How does it work? We have a server that works like an orchestra who send a model to the data holders that can be each device or a whole organization. Each data worker who has her own local data train the model locally on her data in a synchronous way. After this, after they finish the training, they send back the updated model to the server. The server aggregates all the models using aggregation function. Then they send back the new model to the workers that will participate in the next round. We will do the same loop until we have a good model. But one of the main challenges of this approach is the non-independence and identical distribution of data. Each data holder has their own distribution of data. We have different distribution of data. We can have a client that have specific labels and the other has specific samples that will influence to the training of our model, as we will see next in the result section. This is why we developed our framework, which is a generic framework, benchmarking framework that supports different machine learning models, CNN models, STEM models, etc. We also have a different variance datasets, computer vision dataset like MNIST, fashion MNIST, C4, also next character prediction datasets like Shakespeare. But what make our framework specific and unique is that we simulate the non-EED distribution of data, and also we propose some ways to handle the non-EED distribution on our framework. We will see this in details in the next section. Now let's discover the architecture of our framework. You can find all the details and the open source code in our GitHub repository. Feel free to join our community. First, we have a dataset package. Here we have everything that's related to the dataset, the preprocess, the data loader, etc. We have five features here: the EED distribution of data, the non-EED distribution. Here we have two different ways: the random split. We split randomly the data between the workers, or we can split data by labels. We have also three different ways to do this: sharing samples between the class, sharing samples randomly of a specific class, or you want if you don't want to share the class between workers, you can do it. Also, you can share a specific global dataset between all the workers, and also you can add error to a specific worker. We have also a model package here. We speak about the model section. We develop all the models using Torch. You can add your own model. Also, we define the metrics in the model package. We have the aggregation package here that contain two different ways to aggregate the model using the federated average or the weighted average. We also have a utils package that contains some functions that we use in our framework, and also the arguments model. Here you can define your own arguments if you want. The main package, which is run, here we have the two main scripts that we execute. This first script that start the workers, and the second one that they launch the training process. Now let's see how our framework works. First, you should run the first script to allow you to create the workers using the WebSocket on the specific port on your machine, and also distribute the data. You should specify the arguments, the type of distribution that you want, the EED distribution, non-EED distribution, the power of client, the number of client, the name of dataset, all the arguments that are related to the creation of our network. You can find all the arguments on the documentation in our repository. After you create you launch your workers, you should launch the training. Also, we should specify the argument that related to training, the batch size, the learning rate, the aggregation method, the name of model, etc. We have all the argument that related to deep learning training. You can find it there. What happened behind is that we serialize the model. When we launch the worker, we serialize the model. After this, we send the serialized model to the workers. Each worker train on her own local data in a synchronous way. After this, we aggregate the models and we send back the model to the workers that will participate in the next round. We do this until we finish all the number of rounds. Now let's see the result that we get using our framework on the 100 worker. As you can see in the table, we have 5 different datasets using different models. We get some good results on the computer vision dataset like MNIST, fashion MNIST, but in the next character prediction Shakespeare dataset we had the lowest accuracy results, because this dataset contains a lot of labels, and when we distribute the data between the workers, we get this result. What we will see next the result after we add a global dataset on this specific dataset. There's some graphics that show the test accuracy and the test loss on the image dataset in different distribution case, and also the micro training loss and the micro average, the training loss and the test loss, comparison between these two in different rounds. Now let's see the result that we get using the add global dataset to handle this issue of the non-EED distribution on this dataset. We add a global dataset to the Shakespeare dataset. improve the data accuracy in all the N-IID data distribution type, as you can see in the table. This gives us a good result, not a perfect result, but a better result than the traditional way. Thank you for your attention. I wish the presentation was clear. If you have any question, feel free to contact us in our GitHub repository. We will try to answer you the quicker that we can. And feel free also to join our community and contribute to our framework to add more features in the next days. Thank you again.